Mario with MIA Microflight. Today is the first day of the second month of 2026, and this is going to be a long video. I did a short video just discussing this system that I am going to employ on this C-189 Sierra C-189 helicopter. As you're probably aware, if you have been watching my videos, and if you've seen some other people or you have personal experiences with this helicopter, the flyaways is an issue with the flight controller because this is dependent on the barometer and also the optical flow sensor. So there's no way to remove that easily, without going into the code and modifying that, and that requires equipment, and you got to have the proper tools, or some heavy hacking into the code and in the flight controller. So in order to avoid all that, for the average user, I think the easiest way is to retain the 2-in-1 ESC. As I mentioned in my other videos, I show how to connect this, how to power it up, and also how to deliver the signals to the speed controls, pulse width modulation signals from a typical receiver. That way you can control the motors via the existing ESC. You don't need to remove the ESC there. You can just leave that there if you're contemplating doing what I'm doing here with this particular control system as an option. There's a few ways to do this, but I'm going this route here, and I'm going to explain what I'm using here. This is a tiny 6-channel receiver, believe it or not. As I mentioned in my other video, this was sold by Hobby King. Is the orange nano? I believe they call this a nano receiver, R164, something like that. I forget the I forget the model number and designation for this particular receiver, but it's a little tiny receiver, and I bought this to fly install them on 1S LiPo airplanes, my ultralights that I show also in some other videos, flying in front of my cul-de-sac or in my backyard. So they're great for indoor flying. It was designed for indoor flying. Great little receiver. I don't know. I just don't understand why these things disappear. They stop making these things. It's a great little receiver. Yeah, you do have to solder, point to point, to these to the specific channels. You have the throttle, aileron, elevator, ground, rudder. You have gear and CPPM, which is a signal that is used to bind this receiver with a transmitter. You have gear and aux channel, so it's a complete 6-channel system here. So I got a bunch of these PicoBlade receptacles or connectors. These are the ones with 1.25 millimeter separation between the pins, and those are to match the existing connectors on the servos. So so I got 7 of them installed here on this custom 3D printed holder. I designed this little holder here so that it'll hold those PicoBlade connectors. Of course, I have to wire this. I have to run a plus 5 volts bus line and also a ground, and then connect the signal points or the signal pins to this receiver respectively. So let me just put it the way it's supposed to be. It's supposed to be like that. Okay, so next to this is a gyro accelerometer board. This is the MPU6050. You can get those online or through Amazon, eBay, Banggood, Alibaba. I think all those places carry these things. This is an MPU60, like I said, MPU6050, and this is an AT-Tiny 85. No, I take that back. This is the MPU6050 board right here, and this is the AT-Tiny 85 with this is the compact board, which is nicer than the one with the regular USB connector. This one has a micro USB. So both of these boards, of course, you need the proper code embedded in the microprocessor's memory, so that you can operate the gyro. This is this gyro accelerometer board right here, and so this is what I'm planning on using on this particular helicopter is my control system. I have the receiver and I have the flight controller right there. The ESC, I'm going to repurpose this same ESC from here, and do away with the flight controller and the receiver that this unit uses. I won't be using this radio obviously because that only works with that flight controller. So I'll be using just the regular DSM2 transmitter. My orange transmitter that I use with all this DSM2 type receivers, and that's the reason why I got these. Also, these are DSM2 orange. With the same specs as the orange receivers, the larger ones, but in a very compact form. I have used this also on another little helicopter. Actually, I've used that on a couple little tiny helicopters of my own design. That same receiver, so I know it works. It works great. Like I said, unfortunately, these things that are kind of cool and that should be around, they have a tendency to disappear. Good things tend to disappear from the market, and the crappy stuff, stuff like this that you end up in crashes with this. That's that's what they employ on these things. So this is my control system. It's one option. Like I said, it's not it's not a totally it's not going to make the helicopter totally autonomous or semi-autonomous as some of these things tend to do with the barometer sensor and the optic flow sensors. It's not meant to do that. This with a system like this, you are going to need to fly the helicopter. Put the effort in flying. So you're going to be working the controls, the cycling controls to stabilize the helicopter. This is not going to stabilize, in whole height, by no means, because it's not designed. And the code, although the code can be, because this also has a barometer sensor, can be programmed to do that. But I'm not using any barometers. I'm just using this as strictly a gyro system to stabilize the tail and the 3 servos. So this is going to be replacing that control system there. It's a very tiny receiver. I can't get over how tiny the thing is, and it's looking pretty decent, with this 3D printed base. I have to double side tape the receiver here. I'm just going to use that foamy, a really good foamy tape, double-sided tape to hold it once I get down with all the connections here, because I do have to use some very tiny wires, to do the connections from the signal of the connectors to the receiver. So I still have to do that. I still have to connect this, but I'm going to replace these wires because I was using this on a different helicopter, and I had to pull that out so that I don't have to reprogram another one. I do have some more of these boards, but this one's already set up. So all I have to do is just install the PicoBlade female connectors on this board, which are these guys right here. I got a bag of these that come with the female connectors already with the wires and the individual sockets. Those are designed for PC board mounting. But since I don't have the means to do a PC board, with a decent PC board, I could whip one out. I mean, I do have a copper board and PC board material that I could make my own PC board. But to do it properly, you need to do this on the computer and design it properly. And manufacture it properly if you want something a little more professional. But since I don't have those means at the time, I decided to just make this holder for these and gang these up all together so that I can connect it to this receiver. There are 7 of these, and the reason for the 7, I only need 6 here because this is only a 6-channel receiver. The reason for the 7 is so that I can install the LEDs. just use the three pin as a means to provide navigation light, another control system for navigation lights that I show in some other videos. My own navigation lights that I've done, for tiny little aircraft, and also for the bigger ones. They're little boards like that, kind of similar to that size of that board. That use also a little tiny microprocessor to call the code that does all the navigation lighting sequence, in proper form, so that it looks very realistic. So that's the purpose for the seventh connector, just a spare one, if you will. And once this is all set up, I can probably mount this on top of this other one right here. Just like that. And you have that as the flight controller. Cool. Let me know what you think. Mario once again. Thanks for watching.